Hey again, everybody. This video is going to help you with another theorem called the Exterior Angle Theorem. But in order to understand the theorem, you kind of need to know what exterior angles actually are. So in the last video, we talked about how the interior angles of a triangle add up to 180. That's true, and that's great. But you also have angles that are formed outside the triangle. So to get them, you have to kind of imagine an extended line from any side of your triangle. And when you do that, you have all these different exterior angles to choose from. Okay, I could have even extended it this way and had an exterior angle, over here and shaded that in. So it's just an angle essentially outside the triangle, but it's still adjacent to one of the angles inside the triangle. All right, that's exterior. So the way this theorem works is we actually focus on one of those exterior angles, which is right here. So the exterior angle of a triangle is actually equal to the sum of the measures of the two non-adjacent, so don't count the one next to it, so nothing next to C here, but with A and B, the non-adjacent interior angles. So look at the symbols here for this picture. The measure of angle 1 is equal to the measure of angle A, which is here, plus the measure of angle B, which is here. Now they could be different, they could be the same, it doesn't matter, but this one will always equal the sum of those two. You ignore the one that it's right next to, the adjacent one. Okay, in another video I'll prove that for you, but this is the actual rule, this is the theorem. So it's a little different because you're not just adding them up to 180 like you did in the interior ones. You've got one that's on the outside, that's the giveaway. As soon as you see you have an angle outside, you should be thinking like this, where the outside one is equal to the sum of the two inside ones, interior, that they're not next to. Okay, so let's try that out. Find the measure of angle 1. All right, it's a perfect setup. Measure of angle 1 is definitely outside. So the measure of angle 1 equals the sum of those two, 58 plus 72. Notice I'm ignoring this one. I don't need this one. All right, so the measure of angle 1 is 130 degrees, and that's it. This is 130 degrees. Now, you can sort of check it very quickly. Once you know that, if you want, let me grab a different color here. I'll grab a pencil. Oh, preferably one with a tip. So does that work? Yeah. So if this is 130, this has to be 50, right? Because those two have to add up to 180 because it's a linear pair. Well, if those two add up to 130, this has to be 50 also, for the simple reason that those three angles add up to 180. And in fact, I'm sort of proving it for you just with this one example. It's not a real proof, but it kind of explains it. And that's why it works. And in this kind of problem, if you took the time to actually solve for this one first and then find angle 1, I can't stop you. That's fine. It'll still work. But it's not going to help you with a problem like this. Okay, this one, there's no way to figure out this angle with what's given here. So you have to use the new theorem in order to get it. All right, but this is a good example of showing that it works both ways and just showing you kind of an example of why it works. So let's actually do this one the way we need to do it, which is identify where the exterior angle is, which is this one. And you don't have to draw this, I'm just kind of doing it for the effect. And you know that that angle must equal not this and to make 180, but it's literally just the sum of those two. So it's 2x plus 76. It's equal to the sum of those two. And then you solve it like you would anything else. Bring this over, that's 3x. Bring that over, that's 78. So x equals 26. And they want me to actually find the measure of angle BCD, so I got to plug that in. So I'm going to plug that in. 5 times 26 minus 2 is 130 minus 2, which is 128. Let's check it. If this is 128 degrees, that's the measure of angle BCD, right? If that's 128, and this is 26, so that's got to be 52 degrees. What's 52 plus 76? 128. Got it right. Okay. Let's just do these other two. This would probably be a good spot to maybe pause the video, try it on your own first, and then just check your answers. Okay, so hit pause, try this one, and then hit play, and then try this one and hit play again. Okay, so hit pause. All right, welcome back. Hopefully you got it. We do need to find the measure of angle 1, but I can't do it yet because I got to figure out what x is first. So I'm going to do 5x minus 10 is equal to 3x plus 40. This will help me figure out what x is. Solve for x, so that's going to be 2x equals 50, so x is 25. If x is 25, I can plug that back in a couple of different places, whatever's easier, but I'll plug it in here. This is going to be 125 minus 10, which is 115. So this is 115, which means the measure of angle 1 must equal 65 degrees, because 115 plus 65 is 180. So on the side, if you want to do this to help you out, that's fine, but that's going to get you the same thing. You could have done it this way too. You could have plugged the 25 in here. That's 75 degrees. 75 plus 40 is 115. These three have to add up to 180. 180 minus 115 is still 65. But this one you could not have done without solving for x first. Okay? Hopefully that went well. If not, be sure and ask for help. Go ahead and hit pause again and then try example D. All right, welcome back. Here is the solution for example D. Again, I need to figure out what x is, so I can figure out the measure of angle JKM, which is the actual exterior angle. So 2x minus 5 is the exterior angle, must equal x plus 70. Those are the two inside, right? That it's not next to. So I subtract x, I get 75, and actually that's it, x is 75. Put that back in, that's going to be 150 minus 5, which is 145 degrees, and that is exactly the one they were looking for. Actually, in some ways, this one might have been easier than this one. But that's how you do it. Okay? So this one's a little different. This one, you've probably never seen anything like this before, this exterior angle theorem. But it's actually pretty useful in situations like these, where you can't just solve for the missing angle from using the 180. All right, so hopefully that helps. Of course, just feel free to rewind and watch again if you need a little more explanation. But if you need additional help, just ask, and I'll be happy to help. Okay? See you later.